Right, okay, so in today's video we're going to have a look at inequalities. Now we're going to have a look at solving them, putting them on a number line. We're going to have a look at solving inequalities where there's an inequality on both sides, and we're going to have a look at drawing inequalities from a number line and actually saying what they are. So grab a piece of paper, grab a pen. We've got a lot to get through in this one, but we're going to go through it quite quickly, so shouldn't be too much of a long video, but we're covering in the entirety of inequalities here and number lines and solving them. So there's quite a lot to get through, but here we go. We're going to kick off with these sorts of questions where we're solving an inequality and showing it on a number line. Now these are solved in a very similar way to solving equations, okay? But obviously it's not an equation, it's an inequality. It's got our inequality symbol rather than our equal to symbol. So we're going to have a look at actually finding a range of answers here rather than just one single solution. So when we've got a sort of an equation that says 3x minus 5 equals 7, we're finding the exact solution that actually gives us this value. Now this inequality in this question, this is going to run throughout the video, says 3x minus 5 is less than 7. So what we're actually doing is we're finding what values of x would obviously give us answers less than 7. And that's what we're actually finding here when we use this inequality symbol. But as I said, we're going to treat it in the same way as solving equations. Obviously, if you want to get yourselves clued up on solving equations, I'll try and link the video in the description for that, for solving linear equations when we've got an x on one side or on both sides. But we're going to do exactly the same process. So I'm going to assume that we have a good knowledge of solving equations before actually approaching this. So I'm not going to talk about all the ins and outs of how we solve equations, but I'm just going to show you that we're going to solve this in the same way. Now we'll come to actually drawing it on the number line in a sec. So before we get there, we need to actually solve this. So we've got a minus 5 on the left. Now obviously we want to isolate that x there. So I'm going to get rid of this minus 5 to start with. So if we add 5 to both sides, let's have a look what we get there. We get 3x, and that's going to be less than 7 add 5 is 12. So 3x has got to be less than 12. Now we can divide both sides by 3, obviously, because we want to know what 1x is less than, not what 3x is less than. So when we divide both sides by 3, we get x is less than 4. And that is our solution to this inequality here. X has got to be less than 4. Thinking about the logic behind this, look, if you actually put 4 into this equation up here, we would get 3 times 4, this inequality, sorry, I shouldn't say the word equation there. We get 3 times 4, which is 12, take away 5, and that would equal 7. Now, obviously, we want to know what's going to be less than 7, so what we found here is that as long as we put a number in less than 4, it's going to give us an answer there that's less than 7, and that's what we're looking for, which values of x are going to be less than 7. So all we actually have to do now to represent this on a number line is we stick our circle above that number, so above the 4 just here, we'll stick a circle, and it's less than 4, so I'm just going to point it to the left. It doesn't really matter how far I go, I'm just going to point an arrow saying it's got to be all these numbers here less than 4. Now obviously this circle here that I've drawn above the 4, let's do this in a different colour. This circle here can be open, and what I mean by open, just like I've drawn it there, it's empty in the middle, or it can be coloured in the middle. Now there's a little way of remembering whether it's coloured in or not. The other inequality symbol is we could have had this little equal to symbol on it as well. Now that little equal to symbol there has, and this is the way I like to remember it, it's got a little bit more ink on it in terms of when we draw it there's more ink. Now if there's more ink on the inequality symbol, there's more ink in the circle. So if it did have that little line underneath it, we would have a coloured in circle instead. There we go. But as this doesn't have the extra ink on the inequality, we're not going to put the extra ink there within the actual circle above the number. So we're going to leave it as an open circle, but I'm going to use that logic throughout these questions here. When we've got the extra ink on the inequality, we put the extra ink on the circle. That's just a nice little way of remembering it for you. But let's have a look at a different question. Here it is. Okay, so this inequality here, we've got 6x plus 1 is greater than or equal to 2x plus 11. So obviously we've got an x on both sides here, and I'm going to treat that just like when we have equations with x's on both sides. I'm going to eliminate the smallest x from both sides to start with. So the smallest value of x is that 2x there. So I'm going to minus 2x from both sides, which is going to get rid of it on the right. And it's going to reduce this 6x on the left here. So I'm just going to write my working out. I'm just going to write minus 2x here from both sides. And let's see what we end up with. So 6x drops down to 4x. We've still got the plus 1. And that is now greater than or equal to positive 11. So I won't put the plus in. Obviously, if that was a minus there, I'd have to put that in. But there's no need for me to put plus 11 there. Now we can go about taking away the 1 from both sides. Okay, so just like on the previous question, we'll get rid of the 1. We want to get to it. So it says x is bigger than or equal to. So we're going to have 4x now is bigger than or equal to 10. And then we need to divide both sides by 4. And obviously that's going to leave us with a decimal here because 10 doesn't actually divide by 4 perfectly. So if you have a calculator, you can type that in. But if you don't, let's have a look. Let's do this to the right here. We're going to have x is bigger than or equal to, and I'm just going to write it as a fraction, 10 divided by 4. There we go. So 10 over 4. Now, obviously, if you've got a calculator, you can just type that in. But if you don't, we just need to actually simplify that as a fraction. So if we divide the top and bottom by 2, we get 5 over 2, and that's always quite nice. 5 divided by 2 is 2.5, so we've got x is greater than or equal to 2.5, okay? Just remember, obviously, that's nice and easy to simplify. 5 over 2, 2 goes in twice with a remainder of 1, so it's 2.5 or 2.5. So that's not the nicest to draw on this number line, because it's going to be hard for me to get perfectly on 2.5, but I'm just going to do my best. I'm going to put it in the middle of 2 and 3, and this time it's greater than, so I'm going to point it to the right. Doesn't matter how long the arrow is there. And obviously, look, we've got our extra ink on the inequality there, so it can also be equal to that number. So I'm just going to colour that circle in. There we go, and that just shows that it's a greater than or equal to. The extra ink on the arrow, extra ink in the circle. And there we go, that's just obviously how we do that if we've got x on both sides. We just treat it in the same way. Right, we're going to have a look at one more question before you have a go. Right, okay, so this says solve the inequality 2x plus 4 is greater than negative 2, and show this on a number line. So no x's on both sides this time, but we have got that negative number on the right hand side there, so we're going to have to be careful with our positives and negatives here. So we'll take away the 4 from both sides, so minus the 4, and we get 2x is greater than a negative 2, take away 4 is negative 6, so 2x is greater than negative 6. There we go, now we can actually divide by 2 to find out what x is greater than. So divide by 2 and we get negative 3. There we are, negative 6 divided by 2 is negative 3. So I'll put my circle above the negative 3, just showing that we can have negative solutions as well. And obviously it's going to be greater than that, so we're going to point it to the right just to express that it's all the numbers greater than negative 3. And again, I'm not going to colour the circle in there because there's no extra ink on the arrow, on the inequality symbol, so there's no extra ink in the circle. And there we go, that's how to solve inequalities and display them on a number line. So here's some questions for you to have a go at. Okay, so there's 4 questions there, 2 on the left where we've got an x on one side, 2 on the right where we've got x on both sides. There is going to be one of these where there's a decimal solution, so just watch out for that one. But otherwise, have a go at these, solve them, draw them on a number line, pause the video there, and we'll go over the answers in a sec. Right, okay, so the first one, we've got 2x minus 6 is greater than 0. Bit of a weird one there, because we've got 0 on the right, but there we go, let's just follow our normal process, add 6 to both sides, and we get 2x is greater than 6. Dividing both sides by 2, we get x is greater than 3, there we go, and that's our solution. So let's put that on the number line, there's 3, greater than 3, so pointing to the right, and no extra ink in the circle. On to the one below, take away 4 both sides, so let's just write that in, minus 4 minus 4. And let's just take a quick note, that inequality symbol does have the equal to sign, so we're going to be colouring in this circle. So we've got 3x is less than or equal to 15, and then let's just solve that, dividing by 3, and we get x is less than or equal to 5. There we go, so we put our circle on the 5, we'll colour that in straight away, and it's less than, so pointing to the left. Moving on to the top right, x on both sides, so we'll get rid of 3x from both sides, let's just cross this out, and write that here, there we go, minus 3x. So what have we got? We've got 4x minus 5 is greater than or equal to, and you've got to be very careful on this one, because when we get rid of that 3x, it is a negative 9 over there, so I need to make sure I keep that negative in, so negative 9. Now we can add 5 to both sides to get rid of that minus 5, and we get 4x is greater than or equal to negative 9, add 5 is negative 4. Got to be quite clued up with your negative numbers here. And then dividing both sides by 4, we get x is greater than or equal to negative 1. There we go, so over the negative 1 with our circle, we'll colour it in because it's got that equal to symbol, the extra ink on the line, and point that to the right because it's greater than. And there we go, on to our last question. Getting rid of 3x from both sides. And again, just getting rid of our smallest value of x, so it looks like those questions on the left there. And we get 2x minus 3 is less than 4. And again, I don't need to put the positive symbol in for this one. Add 3 to both sides, and we get 2x is less than 7. And then dividing both sides by 2, we get x is less than 7 over 2. And we can probably just divide that straight away. So 7 over 2. 2 goes into 7 3 times, with a remainder of 1/2, so it's 3.5. There we go, so 7 over 2 is 3.5. So as best as you can, put in a circle in between the 3 and the 4, and pointing that to the left as it's less than that. And again, it has no extra ink on the inequality there, so we'll leave that circle open. And there we go, there's our 4 inequalities. Let's have a look at something different. Okay, so this question says, write down the integer values of x that satisfy this inequality and show this on the number line as well. So when we're looking at these integer values that satisfy an inequality, we're looking at what numbers fall between these values here within this inequality. And that inequality just means the numbers between -2 and 3. But if you have a look, this inequality here says it can be equal to that one on the left, but it cannot be equal to this one here on the right, the 3 there. So we've just got to watch out for that, because it can be equal to the -2. So if I was to draw out all the numbers, look, it'd be -2, -1, 0, 1, 2 and 3 between that inequality, but it cannot be equal to the 3, so we just want to get rid of that 3 and just cross that out. Okay, so you can always not write that, so if I just erase that 3 we can get rid of it, but you can always just write them all out and then cross off the ones that you don't need, if that just helps you just to visualize that a little bit. So they are the integer values, obviously integer meaning whole number, so that they are the numbers that fall between that inequality. Okay, so now we need to draw this on the number line. So all I'm going to do is I'm going to pick those numbers there in the inequality. We've got the -2 and we've got the 3. There we go. And it says it can be equal to the -2, so it's got more ink on the -2, so I'm just going to colour that one in. But it can't be equal to the 3, so I'm not going to put the any colour inside that circle there. And all I'm going to do now is just connect them together, just to say that there we go, the number is limited between those two. So it can be equal to -2, but it can't be equal to 3. It can be anything as close as you can possibly think of to 3, but it can't actually be 3 itself. It could be 2.999 and so on, but it can't actually be 3. So there we go, that's how we would draw that inequality there on a number line. Let's have a look at how this changes if there's something else next to the x in the middle and how we'd approach that. Okay, so this says solve the inequality and show it on the number line. So within this inequality here, look, we've got 2x plus 3. Now if I imagine that one of these sides wasn't there, let's just imagine this isn't here for the minute. If we just had that question, look, it's very similar to the one that we had in the first instance. Okay, we just subtract 3 and then divide by 2. Likewise, if we just imagine that the other side isn't there, I know it's written on the other side to what we had before, but again, we just subtract 3 and divide by 2 and we get our solution. Now we're not actually going to do anything different. But in this case, look, when we subtract this 3 to actually start isolating this x, all we're going to do is we're going to take away 3 from both sides. So I'm actually just going to take that away from both sides. I'm going to write -3 and -3. And when we do that, look, -5 take away 3 is -8. And that is the equal to symbol under that. Then we'd just be left with 2x in the middle. And 7 take away 3 there is 4. And there we go. Obviously I want to have x on its own, so now I want to divide by 2 just like we've done before. That'll give me the x in the middle. There we go, keep all the symbols the same. Dividing them both by 2, 4 becomes 2 and -8 becomes -4. There we go, and now it's an inequality that we can draw on the number line. Now we've just got that x isolated in the middle. So it's a very similar process to what we did in those early questions. It's just that when we take away the 3 or potentially add the number if it was a negative in the middle there, we just do it to both sides. And then when we divide as well, just obviously dividing both sides. So very, very similar to what we were doing before. You just have to do it to the left and the right this time rather than just the one side. So again, putting the numbers on these. So -4 we've got a circle on and +2 we've got a circle on. We're definitely going to join them together. I've just got to figure out if any of these are coloured in. So the one on the left there had the equal to symbol right next to that -4. So I'm going to colour that one in just to show that it can actually be equal to -4. Right, there we go. And that is our inequality there, drawn on the number line with a bit of solving in the middle. So I've got a couple of these for you to have a go at, both of them where you're solving in the middle. Again, you could always just think about the integer values that fall into this as well, just as an extra little step. So let's just write down the integer values. So we can have -4, it can be equal to that. We can have -3, -2, -1, 0, 1, and we can't have 2, so if you did write it, you'd have to cross that one out because we can't have the 2. There we go, so we can just get rid of that 2 at the end, and they are the integer values that fall between that inequality there, the whole number values. Obviously we can have decimals in between 1 and 2, we can have 1.5, 1.7, you know, any old decimal that you can think of going in there, but we can't actually have 2 itself, so we won't include that in terms of an integer value. So here's some for you to have a go at. Okay, so there's 2 questions here. It says solve the inequality, and we've got obviously some work to do on both sides there. And then I've put write down the integer values that satisfy the inequality and show this on the number line. So lots to be thinking about. You've got to solve it, write down the integer values and show it on a number line. So there's only 2 questions there, but pause the video, have a go, and we'll go over the answers in a sec. Right, okay, so for this first one then, we need to subtract 5 from both sides to start with. So -3, take away the 5, gives us -8. Write this all in, we've got 4x in the middle, and then 17 take away 5 is 12. There we go. Dividing both sides by 4 then, that gives us negative 2 on the left, negative 8 divided by 4 is negative 2, and it gives us 3 on the right there, 12 divided by 4 is 3. So that is our inequality. Let's straight away just draw that on the number line. So we've got negative 2 and we've got 3, and we can join that up. And the negative 2, we're going to colour that one in. There we go, because that's got the equal to symbol on it. So the integer values that fall between this, we can have negative 2, negative 1, 0, 1 and 2, but we can't have 3 there because that's got the open circle, it can't be equal to 3. Onto the one on the right, add 4 to both sides this time as we've got negative 4. So add 4 to negative 8 is negative 4. That's less than, there we go, we've got the 2x, and then adding 4 to that 6 gives us 10. Now divide both sides by 2 because it's a 2x in the middle, so negative 2. And now we've got the x in the middle and we've got 5 on the right. There we go. So drawing this on the number line, we've got negative 2 with a circle, 5 with a circle, join it up. Be careful at this time the equal to symbol's on the right there, so we're going to colour that one in. And there we go. So our numbers or our integer values that fall between this, we can't have negative 2, but we've got negative 1, 0, and then 1, 2, 3, 4 and 5 there because it can be equal to the 5. Right, there we go. So that is actually solving some of these slightly harder inequalities here where we've got the x in the middle and numbers on either side, drawing them on a number line and writing down the integer values that satisfy that inequality. Let's have a look at one more thing now before we finish, not necessarily harder than these, but just looking at it maybe in reverse. Right, okay, so obviously we've been drawing these inequalities, but actually we could be asked to actually write down the inequality that's displayed on the number line. And obviously we've looked at quite a few different ones here. We've had singular circles with arrows pointing either way, and obviously we've had these joint ones where we've got a circle on either side. So this particular one here says write down the inequality shown on the number line. Now we know what this looks like. And obviously there is an x over here, so we'll have x in the middle still, but it could be a different letter there. I've just used x for these questions, so we know what it's going to look like. We're going to have an x in the middle, an arrow pointing to the left on either side, and one of them has the equal to symbol. Look, this one has the more ink in it, so that's also going to have an equal to symbol. And then the numbers underneath those, we've got 4 and negative 3, so negative 3 on the left and 4 on the right. And there we go, there's our inequality drawn. Okay, obviously you could have some slightly different ones here. I don't really like that highlighter there. Let's make that a bit bigger. There we go. Right, there we go. So what we could actually also have is a number line where we've just got a singular circle. So let's just imagine, look, if I had one above the 1 maybe pointing to the left, that would just be x is less than 1. We could even have one pointing to the right. I could even have it, look, let's do it over here on the 5, pointing to the right, and that would be x is greater than 5, or it could even be coloured in, look, and that would be x is greater than or equal to 5. So all these different kinds of inequalities that we can have drawn on the number line and actually just write those inequalities ourselves. But obviously we've already looked at actually doing them. We're just now doing it in reverse and writing what those inequalities are. But don't remember, all you have to do is write it exactly how you speak it. X is less than 1, like this one, so x less than equal to, less than symbol, sorry, and then a 1, or like the one on the right here, x is greater than or equal to 5, so we just write it as we speak it. Okay, so there's just a couple of ideas of what you could also have, but obviously this question we looked at here was one of these dual inequalities where there's a circle on both sides. So obviously just remember those arrows are both there pointing to the left on this one there, just to show that it's between those two numbers. So I've got 2 questions for you to have a go at before you finish, and here they are. Okay, so this question says write down the inequality shown on the number line. So there's 2 there. Have a go at both of them. Pause the video there, and we'll go over the answers in a sec. Right, okay, so for this first one then, the number is above the 3. So we're going to say that x is, and it's pointing to the left, so less than 3. And the circle's coloured in, so we're going to stick that equal to symbol on it. So x is less than or equal to 3. There we go, and there's our first answer there. The next one, we've got a circle on both sides. So we're going to have our dual inequality here. So both arrows here pointing to the left. The circle on the right is coloured in, so we'll keep that with an equal to symbol. And then the numbers there, we've got negative 4 and we've got 3 at the end. And there is our inequality. X has got to be between negative 4 and 3. But it can also be equal to 3, but it just can't be equal to negative 4. There we go. So that is the end of inequalities. Obviously quite a few different elements there, something different there to finish on, obviously thinking about it in reverse. But that is that. We're going to have a look at drawing these graphically on on obviously coordinate grids if you're doing the higher paper there. That's quite a key topic for you. And obviously some of the other videos on inequalities, looking into quadratic inequalities, which is sort of more towards the grade 8-9 section of this topic. But they're all going to be linked in the description. Hopefully that was useful. If it was helpful, please like, please comment, please subscribe, and I'll see you for the next one.